Okay, let me switch to English because now we have a special guest here, special speaker, my good friend Cedric Clyburn, all the way from New York to speak with us about, what about? Oh, containers and Kubernetes made easy. Okay, so put your hands together for Cedric.
Obrigado. Thank you so much, Elder, for the introduction. My name is Cedric Clyburn. I'm coming to you all the way from, and I guess we can see on that map there, New York City. And it's a pleasure to be here in Sao Paulo. You have a beautiful country. I love it here. It's amazing. Now, my name is Cedric Clyburn. I'm a senior developer advocate at Red Hat. I'm a developer myself, and I'm really excited to share and demo a little bit of containers, a little bit of Kubernetes, and how you as a developer can streamline your container workflow, going from your source code to building and running these container images to Kubernetes, and ultimately save yourself time and streamline that process so that your applications can be designed for the environments that we put them in. So without further ado, we're going to be looking at Podman Desktop throughout this session. Have any of us used Podman or Podman Desktop already? Okay, awesome. Round of hand for you guys. This is awesome. Congratulations. So we're going to walk through a little bit of background on what Podman and Podman Desktop is. We're going to take a look at some of their features, some of the new features that have been added, like the Kubernetes user interface, and also the AI Lab, which in the world of AI now, it can be a little intimidating for a new developer to get started with AI and build really cool applications and features with AI. And so we're going to demo a couple different use cases of AI image to text or working with large amounts of data in the next, say, 30 minutes here. So I say we go ahead and dive in. And the first thing I'll do as a little bit of preface is talk about Podman itself as a project. So you might have seen these guys if you've seen the community or the project on GitHub before, but these are SILs or Selkies. And a little bit of background on the name Podman, how it came to be, is that a group of these is called a pod. So with Podman on our Windows or Linux or Mac OS machine, in the command line, we can work with containers, images, registries, volumes, and much more, but also pods, which helps the migration to Kubernetes environments that we're going to see today. And of course, since we're at the DevNation event, they have their swags and their fedora. Now, the things that you need to know about Podman really quickly before we move on is these two first points of that. Firstly, when you're working with Podman, it's not a monolithic approach, but it's essentially when you create a container, you do a Podman pull or a Podman run in your command line, what's happening is Podman is forking itself. And that's what's known as this daemonless approach. And because of that, we can create containers as non-root users without any background daemon or process running on our system. So for large enterprises that want to use containers but can't give those admin privileges to their users, developers, or operations people, they can take advantage of containers. And so this is why Podman as a project has been really blowing up recently in the open source community. And I do say that because Podman is completely open source and there's no lock-in. So on Podman Desktop, you can even use Docker as a container engine, as well as Podman, of course, and Lima. And finally, it's compatible. So many of us might have came from using Docker and are familiar with the syntax of Docker build, Docker run. And it's the same for Podman with Podman build, Podman run, and all of our container image based on the OCI container spec will then be able to be migrated over to Podman, and you can go back and forth. So it's a great container engine, and it's not just for containers, but also Compose applications. How many of us here work with Compose for their multi-container applications? Awesome. So it is a nice way to be able to put everything together in one file, and Podman now has support for the Compose spec, as well as the Docker socket for tools that I might be using that integrate with Docker now can integrate with Podman without having to do any configuration, and WebAssembly, so you get the benefits of WASM, and you get the benefits of containers. Now, as a development tool, it's wonderful, but also in production, it can be really helpful. So here you can see a unit file for systemd. Well, and there might be some use cases where you don't need a full production Kubernetes cluster, but you want to be able to manage containers. And by using systemd to manage services, we can do the same with containers, be able to define the image, the restart policy, different configurations, so that when we start up a system, it can pull down the latest release of a container image, auto update, And this is really handy for situations where you might not have always connection to internet. So that's enough about Podman itself. It's a tool that I've been using for years, but recently, especially in the past few years since it's GA, Podman Desktop has really came out, and I have to say this, but I really do agree with it. Podman Desktop is the best way for those who enjoy graphical user interfaces or application developers who are working to deploy to Kubernetes to be able to manage containers and their Kubernetes environments. I have a quick question, show of hands, because we've talked about Podman, and that's the CLI, and we're talking about Podman Desktop, which is GUI. How many of us use Vim or Emacs or just like working in the terminal? Okay, sweet. And how many of us enjoy VS Code, enjoy Eclipse, those visual sides? Okay, so we've got a little bit of both. Some people who raise their hand twice. And this is really where Podman Desktop comes in, because I myself enjoy that user interface, but it's also a deeper reason to why Podman Desktop came about. What we realized is that developers, more and more so, are experiencing a difficulty in deploying their applications to Kubernetes because their local development environment, what I'm going to show you today, doesn't always match the environment where we put our applications into production. There's a lot of complexities in the way that I set up things here on my machine and the way that things are set up in production. And we'll show that here in a second. For example, the way that I would map together an application could be through Docker Compose. But when I'm working in Kubernetes, that's YAML, and that's a completely different format of how we want to shape our applications. So there's also that, but also the resources here are not the same as the resources on my cluster. I need to set up different tools and technologies locally that essentially contribute to this kind of wall of confusion between going from local development environments to production. And there's also a skills gap. So going from the development team to the operations team, there's going to be different situations that we're going to encounter. For example, I as a developer might be working with different base images that might not be approved by my security team to be working with Docker Compose, versus on the other side, when I throw my artifact over, the operations team has to work with Kubernetes YAML. The containers are being run as rootless. There's different managed services going on. So how as developers can we ease the migration of going from local to production for Kubernetes environments and get rid of this adoption barrier for using the great benefits of Kubernetes and the cloud native ecosystem that we've come to love, like OpenShift and more. So this is where Podman Desktop comes in, that we're going to be taking a look at today. And it allows us as developers to take our source code, work with containers, work with pods, and ultimately transform that and be able to deploy that straight to Kubernetes clusters versus with local ones on my computer with Kind and Minikube, or OpenShift environments that we might be connected to, or any Kubernetes config that you might have on your local machine. So the goal is to help developers to be able to migrate their applications and be able to detect if there's going to be issues earlier on in the process of developing our applications. What we're going to take a look at today really quickly as well is the Kubernetes integration. So Podman Desktop has been around for about 1.5 years. It's just hit 1.5 million downloads. So thanks to you and developers around the world, people really enjoy this software. And what we've done recently is built out a Kubernetes UI. And this came out at KubeCon this past year. And it allows me as a developer, if I'm connected to my Kubernetes cluster, whether it's local or remote, to be able to understand the nodes, the deployments, the services, the config maps, and much, much more without having to leave my development environment, and to spin up a Kubernetes cluster with Kind or Minikube to be able to develop and test on there. So who's excited for a demo? Woo! Awesome. So I'm going to hop out of here, and I've got Podman Desktop installed. What happens is that on a Mac, for example, it's actually creating a virtual machine with Fedora that's actually orchestrating the containers from there. Windows does WSL2, Linux, containers are Linux. And what we have is Podman installed as the container engine, keeps it up to date. And I've got a lot of extensions that I can add on here, as well as a learning center if I'm a new developer for learning how to containerize my applications. And there's now this nice little extensions and catalog of different extensibility I can add on to Podman Desktop as well. We're going to take a look at the AI features here in a second. But what I want to start out is showing you some of the containers I've been working with. So I could import or load these in, as a container is just a tarball and a little bit of JSON to represent the application. I could pull them from different registries I might be authenticated to, but I want to show you 2 images that I've already tagged here and pushed to a registry that we'll take a look at. We've got a front end and a back end. So let me show you this actual source code. The app that we're going to take from our local environment to production is a simple Python application. Do we have any Python devs in the house? Yes, my people. But don't worry, Elder has you with a Java session right after this. What's happening is we've got 2 imports, just Flask and Redis, connecting to the Redis instance to be able to deliver new hits every time we refresh the application. We're setting this up with this multi-stage Docker file. So we're working with the Red Hat Universal Base Image for Linux to install some runtime tools, build our application, copy in the logic, create a non-root user right here, expose the port, and do an entry point. And the reason we have this entry point, and I want to point this out, is because when we're working with containers and multi-container applications, sometimes we have to do port mapping, we have to do network configuration in order for the containers to talk to each other. But what we're going to see once we turn these containers into a pod is that they can talk to each other on localhost from our local machine, and we don't have to worry about that. But the first thing I'll do is, since I've already built this image, have it here, is start it. So I'll start the backend first. This is Redis here that we've built on top of the universal base image for Enterprise Linux. And we can go ahead and start it. Let me make this a little bigger. Here is where all the magic happens for working with Podman and Podman Desktop. I can give it a name, point to persistent data as a folder, give environment variables, but there's also advanced settings for, say, if the container stops working, we can just restart it. Networking for adding in hosts or DNS servers, and then also seccomp profiles for more advanced configuration. Now, I'm going to just go ahead and start it like that. First off, we've got this container running, the Redis database. Looks all happy here. And what I'm going to do is I'll show you this as well, because we're going to take a look at this in a little bit, is we've got now the YAML for this actual container that we could just drop into a Kubernetes environment, or we could directly deploy it here from Podman Desktop. I'm going to actually inspect the manifest here, and what we're going to do is manually add this IP address, the internal host name here, to the other container's host file so it can talk to it. So we'll go back here, specify that tag. I'll start the other container. We'll call this the Python app that we were looking at. We can see that it's already mapped to port 5001 because AirDrop is used on my Mac for port 5000, and it's very hard to change that. Let me go ahead and add this Redis addition to the host name. And just like that, start the container. Looks like it's running. And bam, we've got our Redis database and our front-end application running just like that. So this is an example, really quickly, of working with multiple containers. So first we have the cache, we have the Python app. Now what I want to show you is this feature of Podman Desktop to create a pod from one or more containers. So we'll call this DevNation pod. And you're going to see that we're only exposing that port for the Python application. And that's because that within the pod, they can talk to each other on localhost, so we don't have to expose the Redis instance. And what's happening is those 2 containers are being stopped. And what we're going to stand up now is a brand new pod with an infra container, the 2 containers that we had earlier, and now the ability to have this Kubernetes YAML file for this application that I, as a developer, don't have to be familiar with. We can inspect it, view the logs, and then restart it. The containers are ephemeral, so they've restarted. And there we got our application running. So this is nice to be able to go from source code to containers to pods. Now, I know you're thinking, well, what about Kubernetes? How do I test that out? I've got an extension here for kind. You can also get it for Minikube, but I can spin this up really quickly. And we're going to kick this off to create a new cluster within a container on our local machine. So we're using Kubernetes 1.3.1 here to prepare the nodes, start the configuration, start the control plane, and now we can test things out in our local environment without having to do any setup. This is all from Podman Desktop itself. So we see those containers that we had earlier, we see the pod, and now I've got this cool control plane to do any kubectl commands and be able to test things out. So I'm going to go ahead, go back to the pod, and that Kubernetes YAML that we had here can now be applied directly to that Kubernetes cluster that we have. So I'll give it the context, the namespace, And what we're going to be able to do is directly apply this to that cluster. So I don't have to leave this environment to start testing out these applications in from Podman Desktop. Now, those are two different containers. And what I can also do to speed up this process is directly push them to the cluster. So I'll just push it to the kind cluster. And now, say if I have a container image that I don't want to expose to the world, I can directly push it to the environment that I'm working to so that I can test these applications out. And so let's go to the control plane. And let's see, kubectl get pods. Both pods are running. They've been pushed to the cluster, so they have the image there. And now on port 9090, which we've created an ingress for directly from Podman Desktop, cool. We can hit the refresh, and I think that's awesome. So say we're doing some testing here. If we want to take this the next step to an actual Kubernetes environment that we have hosted remotely, well, I can just switch my Kubernetes config to wherever the context is. So I want to show you my Teams cluster. Here, if I go over to the nodes and I give it a second, we're going to see that we have all of this compute for my team that I'm able to access. Ooh, a little too small. And what I'm going to do is deploy it. So I'll take the pod that I have running. And remember, this is all within Podman that we've done so far. But now I can actually go and take this to an OpenShift environment. So we're going to see that we still have that same Kubernetes YAML. We've got the front side of the environment, and we've got the back end side. And we're going to just go ahead and deploy it. Now we've taken that YAML, applied it to the OpenShift cluster. It's now running. I can go ahead and open straight to the cluster, to that project. But now we have that new pod that's running. And well, it didn't create the service for it. But what we would have is that full progression that now I can test. I can share this OpenShift environment. And there's an extension for Podman Desktop to allow you to do this, which is called the Developer Sandbox, which allows you to have a 40 gigabyte and 40 gigabyte of storage and 14 gigabyte of RAM OpenShift cluster for you to test things out on. And you can also test that out. For example, I could actually maybe finish up this demo if I go back to here. If I select, let's see if I have it already. Dev Sandbox, awesome, cool. So this is that testing cluster that I just talked about that I am deploying to. So a different environment, I can handle any kube config that I have on my system. And if we go ahead and open up this route once it's ready, we'll give it a second to pull down the container images. Then we can see it. So refresh, fingers crossed. Yay. And just so you can see this, I've actually got a QR code generator, which is also another container. So that if you want to check out this little website that we have running, I'll give you the QR code, and you can actually scan that and get some handy links about Podman Desktop. Podman, we've talked about Podman Desktop and how you can translate your applications to Kubernetes and how it can simplify your life as a developer if you're working with cloud-native applications. But I want to expand just a little bit to talk about the future and what we've been seeing in the developer community. If you're as active on Twitter, or I guess no more Twitter here, if you're as active on YouTube as I am. So let's come back here. And I want to talk and show you this little guy, because we saw those sills before. He looks a little bit different. And this is because as developers, every day there's a new model coming out. There's a new trend in AI that we're experiencing. There's been a lot of new developments in the past year. But I can say in my experience as a developer, about a year ago, 2 years ago, things were much different if you wanted to get into AI. You would be using Jupyter notebooks. You would be working completely in Python. You would essentially have to have a lot of data science or ML experience to be able to use AI. But things are really changing now, and we're transitioning to a new era. There's been a lot of new technologies that we're going to see just in a second that have made your life as a developer easier if you want to get started with AI and build applications that have features of AI for working with large amounts of text, images, audio, and much more. So it is a big journey, but I don't want you to feel intimidated, because what we're going to take a look at with the Podman AI Lab extension that we're about to see is these first two steps, the ideation and prototyping. So if you have a new idea or a use case that you want to work on, how do you test out models? How do you experiment with your data? And then when you build the application, how do you connect to data sources? How can you do RAG, for example, and evaluate these flows and test things out and parameters? And with the Podman AI Lab, the goal was to simplify all of this so that it's much easier to use AI as a developer. So this is just a few months old. At Red Hat Summit is when we actually released this feature for Podman and Podman Desktop. But this allows you to get started with these different use cases for AI that I think you're going to really like. I'm going to show you them here in a second. For working with large amounts of data, images, but also to have a collection of open source models, right? That's a big thing in AI right now, is how can you actually access these models and be able to work with them from your local environment? Let's say I have proprietary and sensitive data that I don't want going to the cloud. How can we keep that on-premise? And how can I use my computer's resources so AWS doesn't charge me a big bill at the end of the month because I love to tinker around and stuff? Now, we're also going to look at running these models locally and setting up playground environments. So I'll show you the demo here in a second, but this is important because of a few reasons, right? As a developer, if I'm running my services locally and building my application locally, I want to have a model that can run locally too. There's a cost efficiency factor in not having to stand up hardware resources or go to a cloud in order to access and work with models. But there's also an education part. As a developer, a lot of us are very new to using AI, but we want to get hands-on with it. And that's exactly what the extension does, and allows you to have full control over your data as well. So without further ado, who's ready for a demo? Woo! Awesome. All right, so we're back here, and bam. I have installed, as I showed you before, the extension catalog, the AI Lab extension, which is going to be this one-stop shop for working with AI. And let me make this a little bigger. So here we have the AI Lab, and this is an extension for Podman Desktop to allow me to get started with different use cases for AI. As a developer, I want to be able to stand up a chatbot that can help my employees talk to the data that we're working with. I could do that through chatbots or RAG systems, which can pull in that enterprise or personal data into the model's prompts and be able to give me a better response back. Now, there's also audio to text. So what we're going to do is use a different model. This is Whisper. It's a OpenAI, open source model. And we're going to start this out here, and fingers crossed we'll be good to go. And what it can do is it was trained with 90 different languages. I love all of these different types of models that you can see on Hugging Face because they're all unique for different situations. And so I could speak to this, this model in English. But I'm going to call on a volunteer here in a second who would be interested in speaking some Portuguese here at the demo to see if we can translate it. So maybe think of some local words or something like that that you wouldn't expect an AI model to know. So what I'm going to go ahead and do is come back to here. And I've got this online audio recorder that tests it out. Hello, this is Cedric speaking. I'm here at the lovely DevNation Sao Paulo, having a wonderful time. So we've got that audio. Let's drag and drop it into this speech recognition application. Give it a second here, and hello. There we go. Sao Paulo. I probably mispronounced it a little bit. So I'm wondering, and there's free swag included, would anybody be interested in coming up here to say some, okay, sweet. My man on the right. All right, let's give a round of applause for him. Thank you. What's your name?
My name is Diogo.
Diogo. Pleasure to meet you.
A pleasure. It's mine.
So, are you ready?
I'm ready.
Anything you want to say, feel free.
Estou aqui no evento da Red Hat. Estou muito feliz por estar aqui e bem animado com isso.
Awesome. Thank you. Okay. So, fingers crossed. We're going to download it here and run it through the model that we have running locally on our machine, right? So nothing's leaving the premise. Thank you again. That was awesome. I'm here at the Red Hat event. Very happy to be here. Very excited about it. Nice. Awesome. That was pretty cool. I didn't know he said. I heard the Red Hat, so I was trying to piece something together. And then even me talking in a different language still understands that and can process it. And I think it's really cool if you have a use case where, say you have agents out in the field and you want them to be able to provide information and data back to back to us, and we want to just allow them to be able to just transcribe it. We can do that with a model that's running locally and build out an application like this. So there's there's the bread again. There's other use cases that I wish we had time for. And for the next talk after this, Elder's going to show some of these examples. For example, RAG or chatbots and summarizers and other use cases in Java, which will be really cool. But what I want to show you is that we can take these models that we have downloaded on our local machine. For example, that translator, the audio model, we have that here, and it's about 500 megabytes, and it uses about the same amount of RAM. So you can see that we don't need a huge system with GPUs in order to start using AI. We can get started locally on our machine. So what I want to show you is this model that we have here. This is Granite. It's a model that was open sourced by Red Hat and IBM back a few months ago. And what's unique about it is you can actually look up all of the training data. A lot of models nowadays, we don't really understand what they're trained on because it's kind of the secret sauce of how they're built, right? If they told us, then everyone would do the same thing and there'd be no competitive advantage in AI. But this is a different approach. So we know how the model was trained. I'm going to copy this container port here. And just like this, we can stand up a large language model locally on our machine to be able to query it, to be able to use it in our applications. For example, if I just copy this code here and throw it into the terminal, then I'd be able to get a response back from the model that's running locally. So let's try that. What is the capital of France? I'm French, so I hope it knows. Capital of France is Paris. Awesome. It's a close one. So we have this model running locally. It's Apache 2.0 license, so we can use it in a large amount of ways. As you can see, it came from Hugging Face, so if we want to import other models from Hugging Face, we can do that. We've got a Swagger interface for understanding the API. So as you saw, it called this specific API to see what was the capital of France. And we were able to get that response back, just like this, to be able to test out the model and all the different endpoints. I want to show you that bread again. Hold on. I want to show you that, say if I'm a Java developer or any other type of framework or language, I have the ability to quickly get started building out AI features in my application. So any Java developers in the house? Okay, awesome. Good to see y'all. If I was building out a Quarkus application, I could just add this to my application.properties, add the dependency in there, and then create a service to just input my question, just like that. That's all I have to do to get started using this AI model locally on my machine. So it makes it very simple in order to get started, but let's actually see that in action. So here I have the model running on localhost. It's using GPU inferencing, but if you don't have a GPU and you're just using CPU inferencing, that's okay too. I've got this Quarkus application running, and I don't know much about Java, so I hope nothing goes wrong. But what I want to do is be able to add a chatbot to my application. So this is this insurance application that you saw earlier today, where our insurance adjusters are processing these claims, and we want to speed up that process. So what we can do is add in a chatbot. But right now, we've added the functionality for the chatbot, but not the model. So if I want to ask a question, what happened? Question mark, question mark. Well, there's no connection right now to that model. And so you're going to learn about it more in the next session. But LangChain for J and LangChain in general is a way to simplify requests to these models. So if I provide the, if I provide the correct port and some information about the temperature parameters for the model, then in real time, and you can see there was an error in that request, we can ask a question to the model. So let's refresh the page. Let's ask a question about some of the data here. What's the contact info? So in natural language, I, as say someone in the organization, could ask a question about the specific data that we're working with and be able to get a personalized response by using one of these large language models. So it tells me, hey, this information is blank and blank. Now let's go a little deeper. How does this work? Well, we're actually creating a service in Java that's providing a system message and a user message, like just how we work with large language models like ChatGPT and Llama. We're doing the same thing here, but all locally. So we're giving a message of, hey, you've been given a summary, provide a helpful response. The summary is provided in that variable, but we also have the question provided. And so if I scroll up, we can see this is provided in tokens, but behind the scenes, we're actually making a request to the model that's running on localhost. We're saying, hey, you're the helpful assistant. Here's information about the claim. And the question from the user, well, that's provided in this request, this post request. And just like that, we get a response back from the model. So this is a great way to be able to start building out these AI features in our applications by simply putting up and standing up a service for the AI model, and then having the code to integrate this into our application. Here and kind of close out, because we've talked about a lot, but I really think this is a really cool feature for developers who want to use AI because it's so easy to get started. So this is the AI Lab, and let me come back here to where we have the slides, and I'll kind of point you to some really cool resources to get started. And lastly, I also want to say that for our applications, containers have been really great to distribute applications, to scale things up, and have flexibility. And the same is true for AI. AI is very new to a lot of us, but it's another tool that we can take advantage of to build out great applications. And so whether you're running it locally or in production, AI can benefit from containerization. And there's GPU enablement as well. So if you're on Windows, Mac, and Linux, you can use your GPU that you might already have to speed things up and get responses faster. So that was the Podman AI Lab that we just took a look at. It's the newest feature of Podman Desktop. But I want to point you to some cool resources if you want to take a look at all of this. So, and quickly, I'll point out that if you're working with OpenShift or Red Hat technologies, there's different extensions for OpenShift Local, the SSO image checker in order to see if there's any common vulnerabilities in your applications, and bootable containers so that you can actually take your application and build out a virtual machine image to run on various types of hardware. So finally, the how to get started. So I encourage you, if you've enjoyed and learned from this, to check out Podman Desktop if you haven't already, to go to the GitHub if you have any issues or want to contribute a new feature, and to get involved with the community. It's a completely open source project that is, a lot of features have been created by people just like you. And it's really been great to see how it's grown in the past year and a half since it came out. So with that being said, I want to thank you. Obrigado.